over a pulley. Object A has a mass of 18 kilograms and object B has a mass of 12 kilograms. What is the acceleration of the system? Well, looking at the diagram and reading the question, we realize that object A is heavier. So we need to look for that because that's going to tell us what direction the pulley is going to turn. Since A is heavier, A will pull B upward. So that means that the pulley will move in a counterclockwise direction. So that's important to realize initially, because what we want to do with that information is we want to establish what is the direction that A is moving, and what is the direction that B is moving. A and B, or B is trailing A. So what I like to do is I like to pick the lead of the travels. So A is leading B. So I'm going to say that A is moving in the positive direction. And because I made that choice, that must mean that B is following A in the positive direction also. So when it comes to drawing the free body diagram, we need to use those two coordinate axes that I just drew in green. So let's draw the free body diagram for A. So there's A. And A has gravity pulling downward on it. So that would be FGA. And we have tension of the rope pulling upward. Those are the only two forces acting on A. B also has gravity going downward, FGB, and it also has the rope pulling B upward. Now, as I stated earlier, the direction of motion for A is down, and we decided to make down the positive direction for A. And since A and B are connected by the same string, we look at what is the direction that the string moves. And since the string for B is moving upward, we say, in terms of B, where it's connected to B, that part of the string is moving upward, we say that B is moving in the positive direction. So now what we're going to do is we're going to write out a Newton's second law statement for each object. I'm going to do this a little differently this time. I'm going to state that the sum of the forces acting on A is equal to MA times A. I guess I should have earlier stated that the acceleration of A is equal to the acceleration of B. That's useful to state right at the beginning of the problem, but you can always do it later. And the sum of the forces of B is equal to MBA. Since the two weights are different, we know that the system will accelerate. The object A and B will move because A is heavier than B. So there's no question that we have an acceleration here. Now, if I write out the sum of the forces for A, I'll do that over here. We have in the positive direction, the weight of A minus the tension is equal to MAA. So that's that. And now what I'm going to do is directly underneath, I'm going to write the Newton's law equation for object B. Object B would be tension minus FGB is equal to MBA. And now what I'm going to do with those two equations is I'm going to add them up. I taught you that technique before. And when I add these up, you can see that the T's will cancel. And I'm left with FGA minus FGB is equal to MAA plus mba. And I can expand the FGs. That would be mag minus mbg is equal to maa plus mba. And if you look, I can factor out the g on the left side, and on the right side I can factor out the acceleration. So I can simplify my equation as ma minus mbg, factored out the g, and here I have ma plus mb, factor out the a. So I can rearrange everything to read the acceleration is ma minus mb over ma plus mb times g. And I'm not going to plug and chug the numbers here. That's not as important as realizing how do you get to this step. And I just want to end by saying that if we have multiple objects, like let's say that we have something like this, where we have a pulley and we have object A of some mass and object B of some mass and object C of some mass, anything like that. All we need to do is figure out what direction does the pulley turn. And if we can figure that out, then we can very quickly come up with the acceleration formula, because the acceleration formula is the ratio of the difference in mass, or in masses, divided by the sum of the masses. And that will end up being, times g. So the acceleration, difference in masses divided by the sum of masses, and that's on either side of the pulley. So that's how we figure that out. So for now, for homework, what I'd like you to do is solve the problem using that method. And then after a while, when you gain enough practice, you may be able to just scooch straight into this idea where you can come up with the acceleration based on your understanding of this device, which is called an Atwood's machine.